Bismillahirrahmanirrahim. So next, let's look at example number 3. So here we are given a hypothetical gate as shown in the diagram, and then we asked to determine the hydrostatic force acting on this gate. Okay, so here is the schematic diagrams of the problems. So if I consider this volume above here, so if I call that one here volume 1, and I call this volume here made up of this as volume 2, and then this volume I call this volume 3. So first of all, let's consider the vertical component of the hydrostatic force. So on surface CD, the force will be acting downward. So the force here, F vertical CD, is actually equal to rho GV1, right? What about on surface BC? So the force, again, since the water is above the surface, so the force will be acting downward. So this is F V B C, right? And since this volume and these volumes are the same, so the force are actually the same. So that's equal to rho G V2. And then we know that V1 is actually equal to V2, right? And what about this surface here? This surface here, the water will be underneath the surface. So the vertical force will be acting upward. So F vertical BA will be equal to rho G. But which volume we have to consider? It's going to be the volume above the surface. So it will be volume 2 plus volume 3. So now what about the horizontal component of the force? So first of all, horizontal component of the force acting on surface CD. So in order to do that, we need to project the surface on the vertical plane. So what we do, we will obtain this surface whereby this distance is equal to the width of the gate, and then this will be the h bar vertical, right? So the force will be acting this way, right? So it will be equal to F horizontal CD will be equal to rho G h bar vertical, I call that h bar vertical 1, and then A vertical 1. So A vertical 1. Right. What about on this surface here? On this surface, if we project, we will get the same surface, but now this way. So it will be acting that way. FH BC. The magnitude will be the same as this one, right? And what about this surface here? So this surface here, the horizontal component will be acting this way. So that will be equal to FH BA. But then in order to calculate this, we need to project it here. So we will obtain this whereby this distance is again equal to the width of the gate, but then the h bar will be from here to here. So that will be equal to h bar vertical 2. Okay, so the force there will be equal to rho G h bar vertical 2 A vertical. A vertical 1, A vertical 2 is the same, right? Okay, so basically that's the magnitudes and the line of actions of all the components of hydrostatic force acting on this gate.